In our last chapter, we worked with things like this, x equals 17. Well, there's only one number that equals 17, it's 17. Today, we're going to be talking about inequalities, which are greater than, less than, greater than or equal to, and less than or equal to. Well, how many numbers are greater than 17? There are infinitely many. So we're starting to enter a world where we have lots and lots of possibilities for our solution. So our first task today is going to be to graph the inequalities. I've given 4 here. X is less than 3. So we want to draw a picture of all numbers that are less than 3. So 1, 2, 3. We have numbers that are smaller than 3, which will be everything over here to the left side of 3. So to indicate that those are the numbers that I want, I'm going to shade all of those numbers. We'll come back to all of these in just a second because there is something that I need to introduce. All right, this one is y is greater than 5. So here's 5. We need numbers that are bigger than 5. That means we have all of the numbers that are on the right-hand side of 5 that work. So I'm going to shade over here. And you'll notice that I put an arrow at the end of my shading to indicate that it continues on forever in that direction. P is less than or equal to -1. So here's -1. We want numbers that are smaller than -1, so that would be again to the left-hand side. Our smaller numbers are always on the left-hand side. And our larger numbers are always on the right-hand side. So we have S is greater than or equal to 0. I wanted to highlight this one because sometimes people freak out about the number 0. The numbers that are bigger than 0 are again over on the right-hand side. Okay, now there's one more detail we have to talk about. What about the number 3, 5, -1, and 0 itself? That's here at the end of this shaded area. X needs to be less than 3. We do not want x to be equal to 3. However, in this case, we're allowing the p to be equal to the -1. So we need to show those two different situations where we're not allowing it to be equal or we're allowing it to be equal, and we do that using open and closed circles at the end of our shaded area. So right here, an open circle means that we're not allowing it to be equal to. So here at the 3, I'm going to put an open circle there showing that the 3 itself doesn't work. That's where the line starts, or the shading starts, and it goes over to that side. We're not allowing y to be equal to 5, so again, I put an open circle here. On this one, we're allowing the p to be equal to the -1. I want to include it, so I'm going to put a closed circle to show that -1 works. And here we're allowing s to be equal to 0. So again, I put a closed circle. So whenever we're allowing it to be equal, it's a closed circle. If we're not allowing it to be equal, it's an open circle. Let's take a look at 4 example graphs, and our next task is to write the inequality. So you'll notice that we have our variable needs, or our numbers are all bigger than 2. So I'm just going to call x for our variable. We need those to be bigger than 2 because it's shaded over here to the right side of 2. 2 itself works because it's a closed circle, so we're allowing it to be equal to. So I'm going to include that right there. All right, we need again our bigger numbers. This is going by tens. It's here at -40. So our numbers x need to be bigger than -40. And we have an open circle here, so -40 itself doesn't work. We're not going to put equals right there. On this one, we have numbers that are smaller than -1, so our x needs to be smaller than -1. And again, we have an open circle, so we're not allowing it to be equal. I'm going to leave that out. And here we have our x's are smaller than 10 over here on that side. And we have a closed circle, so we are allowing x to be equal to 10. And I also wanted to highlight this number line. You'll notice that there's no 0 on this number line. You do not have to have a 0 on the number line if it's more convenient to number it in some other way. Thank you.